Earth is the blue planet, the water planet. On Earth, water is the key to all life. Oceans cover 71% of our planet's surface. Populations rely on them as a vital source of high-protein food. 90% of our goods are transported at sea, and the oceans hold a tremendous supply of critical resources. Through currents and heat transfer, oceans dictate what parts of our land, even deep within the interior of a continent, are fertile, desert, hot, or cold. It is the ocean's warm surface that feeds energy to weather disasters such as hurricanes and typhoons. In addition, microscopic oceanic plants consume some 50 gigatons of carbon per year, about the same as all the plants and trees on land. We depend on the oceans more now than at any time in history, yet it is this majority of our planet that we know the least about. Realizing this lack of knowledge, researchers are now implementing many tools and technologies as part of the global Earth observing system to enable a deeper understanding of the oceans. Thousands of automated robotic floats drift with currents at depths of up to 2 kilometers, sampling pressure, temperature, and salinity. The data collected helps scientists measure conditions driving climate change. Across the equatorial band, an array of moored buoys measures temperature, currents, and winds, allowing scientists to study and predict the signs of El Niño and other damaging weather patterns. Allying with animals as oceanographers, we are able to sample conditions in some of the most inhospitable areas of the seas. These elite creatures carry small computers along their migratory routes, gathering data across tens of thousands of kilometers. Initiatives like these, as well as many others such as underwater cabled observatories, are beginning to cover the expanse of our oceans. Add to this mix valuable tsunami warning systems protecting some of our coastal regions. Unfortunately, not all coastlines of the world benefit from such technologies. In fact, our global ocean observing system is sparsely deployed, inadequately funded, and a higher degree of international cooperation is needed. There is much at stake. Studying the role of plankton in the planet's carbon cycle and documenting the rise of sea levels will help us understand changes to our climate. By plotting shifts in currents and heat transfer, we can better protect coastal populations and industries from ocean-based disasters. By tracking the creation of weather patterns such as El Niño, we can prepare agricultural regions for flooding and drought, and world populations for harsh winters and heat waves. And finally, as we overfish, pollute, and destroy coastal habitats, what is the long-term human impact on our seas? Historically, we did not have the ability to study the oceans. This is no longer the case. The technology exists now as part of the Global Earth Observation System of Systems. And now is the time for action. Only when we have a sustained effort with full international involvement will we unravel the mysteries of the ocean and reveal its impact upon us all.